Let's recall where we are right now. We have a collection which has the actual walk in it. We collect where that walk ends in a place called measures, and that's here in this end column. We've done this 200 times and we've seen what the distribution is of our ending positions. This is a sampling distribution. We've also defined a number of measures on this collection, including the percentiles, 5th and 95, and all of these other measures of spread to see how spread out this distribution is. Now we want to do this over and over again with different original sample sizes. Right now we just have 2. What would this distribution look like if we had more? We're going to do that in a moment, but first, let's collect measures from here so that we can see that we're getting the numbers we expect. So I'm going to do collect measures from the measures collection. When we do that, we get a new collection named, strangely, measures from collection 1. And we have its collect measures panel open right now. In this panel, I'm going to turn animation off. I could leave this at 5, but the instructions have us go to 1, so let's go ahead and do that. At this point, I recognize that I've forgotten to do step 5. And step 5 on the correct 2-column handout has this very important step. I'm going to look once again at the measures, the collect measures panel from the middle collection. This is where we specified 195. Let's make this actually be 1,000 each time. And I'm going to select replace existing cases. The reason for this is that when I change the sample size and I redo things, I don't want these old measures sitting around. I want them to be cleaned up. I will have collected them already in measures for measures, so that'll be fine. Before we get started, let's make a table of this measures for measures. I'm going to use a fancy technique. I'm going to take the name measures for measures, and I'm going to grab it and drag the name into the middle of this table down here. Now I can see my various measures of measures that I'm collecting. I have my 5th percentile, my 95th percentile, margin of error. Mean absolute difference varies, but it centers around 1, and SD varies, but centers around the standard deviation. Let's now make a new graph, and I'm going to put the sample size on the horizontal axis, so we have a bunch of 2s here. I'm going to put standard deviation on the vertical axis. We can see they're all spread out like that. So now I want to increase the sample size. So I right-click, I'm going to do new cases. Let me get 3. So now I have a sample size of 5. If I go here to my measures from measures collection and click collect more measures, I now get 1 standard deviation from n equals 5. And that, of course, has rescaled the graph. I'm going to do it again just to see if it came out the same. It came out pretty much the same. Back over here, new cases. Give me 5 more. I'm going to collect again. Now I have some data at n equals 10. And the standard deviation is about 3.29. Mean absolute deviation is 2.6, and margin of error is 6. Over here is what the end distribution looks like. I've taken random walks with 10 steps, a whole lot of random walks, 1,000 in this case, and here are the various places where my 1,000 random walks ended up. Usually it's near 0, but a couple times it's been all the way out at 10 and minus 10. So that all makes sense. Let's do walks of 20. So I'm going to add 10 more and click collect more measures once. Look at that. Now we can see it's kind of curving just a little bit. We've got a little bit of data at 20. Let's take 30 more and we'll get data at 50. So there we are at 50. I'll make a couple of these just to see how different they are. Let's make 50 new cases and we'll collect them at 100. Every time I click this, we're taking a random walk of 100 steps, and we're doing that 1,000 times and taking that result and calculating all of these measures on that distribution. So here, for example, margin of error, 16.5, 90% of the walks between the 5th percentile and 95th percentile, 90% of the walks are between minus 16.5 and plus 16.5. My average distance from the center is about 8, and the standard deviation of my distances is about 10. Curiously close to the square root of 100, our sample size. Let's continue. Add another 100 cases, collect more measures. There's a point plotted at 200. 300 more cases. Now it's starting to take a while. There's a point at 500. This is probably enough. Look at the pattern. Let's see if we can find a function that matches this. It looks kind of like a parabola, but on its side. Let's try plot function and say the square root of x. What will it be? Wow, this function works pretty well. Let's make the points bigger. This curve works pretty well at modeling these dots. And this is exactly what we use later on in order to find the standard deviations of various sampling distributions. This random walk is at the root of how binomial situations work. That is, it's either one or the other. In this case, a success was +1, a failure was -1. When you've done this a bunch of times and added up all your successes, how far are you likely to be from the origin? Answer is the square root of n.